This video is brought to you by mywayteaching.com.
Next concept is intermolecular forces. Here, intermolecular forces are the forces of attraction and repulsion between interacting particles. Here, interacting particles means atoms and molecules. These are called interacting particles. Okay, so here this term does not include the electrostatic forces that exist between the two oppositely charged ions and the forces that hold atoms of molecules together, that is covalent bonds. The intermolecular, this term what we are saying about intermolecular forces, it does not exist and it does not include the electrostatic forces. Okay, and next, attractive intermolecular forces are known as van der Waals forces. Attractive intermolecular forces are known as van der Waals forces. Okay, so van der Waals forces were considerably in magnitude and includes the uh, dispersion forces or London forces, okay, or dipole forces and dipole induced dipole forces. A particularly strong type of dipole interaction is hydrogen bonding. So strong type of dipole interaction, strong type of dipole dipole interaction, that is hydrogen bonding. Okay, and so here only a few elements can participate in hydrogen bond formation, therefore it is treated as a separate category. And at this point it is important to note that attractive forces between an ion and a dipole are known as ion dipole forces. Attractive forces between an ion and dipole are known as ion dipole, and these are not van der Waals forces. Okay, so this is about intermolecular forces. Next is topic is dispersion forces or London forces. Okay, atoms and non-polar. Okay, see here, atoms and non-polar molecules are electrically symmetric and have no dipole moment because their electronic charge cloud is symmetrically distributed. Okay, atoms and non-polar molecules. Atoms, we know what is atoms, and non-polar molecules are, they are electrically symmetrical and have no dipole moment because their electronic charge cloud is symmetrically distributed, but a dipole may develop momentarily even in such atoms and molecules. Dipole may develop. Okay, so consider, I will give you one example and you can understand this topic easily. Okay, see here, this is the figure A. This can be understood as follows, like suppose we have two atoms A and B. So this is A and this is atom B. in the close vicinity of each other. So as shown in this figure, this is the figure A, this is figure B, and this is figure C. Huh. So it may so happen that momentarily electronic charge distribution in one of the atom, say atom A, because atom because A, okay, becomes unsymmetrical. That is, the charge cloud is more on one side other than that. Okay, as shown in this figure C, this is figure A symmetrical distribution of electronic charge cloud. Here, what happens? Atom A with instantaneous dipole, more electron density on the right hand side. Here on the left hand side. So, this is insymmetrical in nature, but in figure B and figure C, what happens? The charge cloud is more on any one side, that may be right hand side or left hand side. So this results in the development of instantaneous dipole on the atom A for a very short time, so that here what happens, instantaneous dipole will be created. Okay, this instantaneous or transient dipole distorts the electron density of the other atom B, so it also distorts the atom B also. Distorts the electron density of the other atom B, which is close to it, and as a consequence a dipole is induced in the atom B also. Okay, next, the temporary dipole. So here in the atom B, this is atom B, in the atom B also there is a induced dipole. Okay, dipole is induced. The temporarily dipole of atom A and B attract each other. Similarly, temporary dipoles are induced in molecules also. This force of attraction was first proposed by the German physicist Fritz Landon, and for this reason, force of attraction between the two temporary dipoles, they are known as Landon forces. Another name for this force is dispersion force. These forces are always attractive. Okay. Uh, See, as I'm explaining you about this is dispersion forces or London forces. So you understood the concept of this symmetrical distribution, and here on any one side of the atom there's a dipole induced, so that in the atom B also there is a induced dipole, and in figure C also the same thing happens. So, and you should know what do you mean by London forces. So here the temporary dipole of atom A and B attract each other. Write down this. Temporary dipoles of atom A and B attract each other. Similarly, dipoles are induced in molecules also. This force of attraction was first proposed by similarly temporary dipoles. So similarly temporary dipoles are induced in molecules also. This force of attraction was proposed by the German physicist Fritz Landau. So, and for this reason, force of attraction between the two temporary dipoles is known as. So, this is known as this temporary dipoles. Dipoles are known as London force. Another name for this is also called, or this may also called as dispersion force, always these forces are always attractive, and they are inversely proportional to the sixth power of the distance between the interacting particles. This force is inversely proportional to the this one. Okay, so please note it down. And these forces are important only at short distances, and their magnitude depends on the polarizability of the particles. Okay, so just a glance on this topic. What do you mean by dispersion forces or London forces? This is just like an introduction. After that, you can explain what do you mean by London forces. Okay. Here you can see here. This is about the London forces, and this is the dispersion force. And write down. And the next here, it is figure A, and here how the electronic charge is distributed, and this is figure B, and this is figure C. Okay, so this is about dispersion forces or London forces. Next topic is mm, dipole forces. Next topic is dipole dipole forces. What do you mean by dipole forces? Dipole forces act between the molecules. Okay, this will be happens in the molecules. It should be very important term. And possessing permanent dipoles. End of the dipoles possesses partial charges, and these charges are shown by Greek letter delta. Okay, see, we know that partial charges are always less than the unit electronic charge. This is the partial charges means which is less than the unit electronic charge. We know electronic charge is 1.6 into 10 raised to minus 19 coulomb. Okay, here the polar molecules interact with neighboring molecules. So this is the figure A. Here as shown in this figure, electron cloud distribution in the dipole of hydrogen chloride. We are seeing that HCl. Okay, how it is distributed. And one other figure I will show. This is the dipole interaction between two HCl molecules. There are, this is one and this is two. Therefore, there are two HCl molecules are present. So this interaction is stronger than the London forces, but is weaker than the ion-ion interaction because only partial charges are involved. Here, only partial charges are involved. See here, two in between the two molecules, it is there means it is stronger than London forces. Note it down, and it is weaker than ion interaction. Okay, so because only partial charges are involved, the attractive force decreases with increase of distance between the molecules. So here what happens, attractive forces attractive force decreases with increases in between the distance between the molecules. Okay, the increases of distance between the dipoles. So as in the case about I have explained you in the dipole ion, that is London forces. So the interaction energy is inversely proportional to distance between the polar molecules. But in dipole-dipole interaction, energy between the stationary polar molecules is here it is forces is inversely proportional to the stationary polar molecules is proportional to 1 by r cube, and the between the rotating polar molecules, which is this is for stationary polar molecules. Okay, And for rotating polar, what happens for rotating polar? It is in proportional to this one. Okay, so this is for rotating polar, where r is the distance between the polar molecules. Besides dipole-dipole interaction, polar molecules can interact by London forces also. The cumulative effect is that the total of intermolecular forces in polar molecules increases. Okay, so this is about the dipole-dipole forces.